So in this case, guys, we are going to consider our nature of roots, which is part of our equations. As we are working with our equations, there's a part that you need to understand to give the roots their nature. So you had this before, okay? I want you to remember this. You had something of this nature, an equation, which is a quadratic equation, where the highest exponent is 2. A quadratic equation. You solved this using any of the methods. Is it the completing of the square? Is it the quadratic formula? Is it the factorization method? Then you had the roots or the solutions. So when you were solving, I want us to focus on the quadratic formula. All right, using quadratic formula. You're going to understand each other very soon using quadratic formula or using the quadratic formula. We do understand that on our quadratic formula, we can use it provided that the equation is in this format. That is the format of ax squared plus bx plus c is equal to 0. This is the format of our equation to be solved. The quadratic equation to be solved. By which formula? By the formula x is equal to minus b plus or minus the square root of b squared minus 4ac everything over 2a. This is the formula you are supposed to use. And you substituted your values, all right, as we had. These guys, this is just a recap. We have been working on this. So the coefficient of x squared, as we have, this is our a. What is corresponding what? To x squared. So in our case, that's a 1. If you are not having a value there, that means you are having a 1. So our a is 1. Our b is the coefficient of x, which in this case is -5. Our c is the constant, which in this case is 6. So you're going to substitute these values. Minus b, our b is what? -5. So this is -5 plus or minus the square root of b squared again. So that's, the b again, but being raised to the exponent of 2 minus 4 times a. In this case, we said our a is 1. Our c is what? 6. All right, so everything is over 2 times a. Our a is what? Is 1. If you still remember, guys, properly, for those that have been part of our classes, I said when you are solving the quadratic equation, try by all means to show the examiner this part, to show the marker, this part here. When simplified, try to show that part. So you're going to have a minus, and minus is what? Plus. So that's 5 plus or minus. We are going to have the square root of what? We simplify that part alone. And that part that I'm saying now that you're supposed to simplify is the major part of our introduction to the nature of roots. And I've been talking about that. Okay, so let's simplify this, guys. All right, this is -5 squared -4 times 1 times 6, just like that. That's a 1. So you're going to obtain the square root of a 1. Everything over 2 times 1, which is what? Which is 2. So from there, you can have our x values. From there, the simplification does not matter, guys. We can just simplify at once. 5 plus the square root of a 1. Everything over 2. That is going to give us what? A 3. Or we have another value of x. When this x is what? Okay, when we put a minus here, sorry. When we put a minus, what is the value of x? our x is going to give us what? A 2, positive 2. So this is it, guys. You solved an equation, which is a quadratic equation. So, and obtained 2 solutions. So in our case, this is our case, guys. You understand me very soon. Remember, we want to understand the nature, like to say, what exactly are the types of roots that we have, the type of root that we have, the nature of the number. Guys, the roots is just like, these are the solutions. Remember, when you're solving an equation, these are the solutions. So do not worry about that. So it's just like the nature of a number. When you are given a number, which is, let's say just something like this, so that you understand me properly. You are given a number which is 2. How can you describe 2 as a number? 2, this 2 as a number. How can you describe it? The first thing, it's a real number. It's a real value. It exists. Mathematically, it is something that exists. It has been simplified 2, which means we are talking about being a real number. It is also a rational number. By just looking into these 2, 2 can be written as a fraction. Remember, 2 over 1, a over b, a rational number. Irrational, those are the numbers that we can't simplify. Like direct, we can't simplify them. The calculator can, but us, we can't. These are irrational, but this one is a rational. This is like the nature of a number, looking into it. The moment you say rational, you have covered a lot of things. You have covered all numbers there, integers. This is about this number. So the rational number becomes like the mother name, because when you say rational numbers, you are including all integers. You are including all integers, remember, from your grade 9, yes. All proper fractions. All, let's just say, guys, for fractions, let's just say all fractions. All fractions. Proper fractions, improper fractions, mixed fractions. All of them. Decimals, which are terminating. Terminating this. Remember all these guys, these terminating decimals, all the recurring decimals. All recurring decimals. Those are decimals such as we write 0.45. We write it like this. All right. So as you can see, the moment you say rational number, you've covered all this inside of it. So you must be careful about being just a rational number. So in our case, guys, let me quickly go to our topic so that we understand each other. In our case, the number, just like a 2 that we're talking about there, are these 2 numbers here, which are the roots or the solutions. These are the roots of an equation, of a quadratic equation, or the solutions to our quadratic equation. So you want to tell the examiner that what type of a number is this, and also what type of a number is this. But you are doing it without solving this equation as we did here. Here we had to solve. So it does not make sense now to say we solve it, then we say, okay, the roots are real and rational. We want to do that without the solving of the equation. But as we saw, guys, we're going to have what? 2 solutions on a quadratic. This is just a recap, a reminder to you. And also, as part of your simplification using the quadratic formula, I also want you to get rid of this, to take note of this, your quadratic formula, this part, the simplification of that part, because it is going to help us. The simplification of that part. All right. So into our nature of roots as a topic. This is the idea, guys. They want us to determine the nature of roots, to tell that the numbers, are they real numbers? Are they going to be non-real? These numbers that we are going to have at the end, what are they? But we are going to do it without solving. Because if you are given a number direct like this, square root of -3, and you are given, tell us the nature of this number. What can you say, guys? What can you say about square root of -3? Is this a real number? Is this a rational number? What can you say? Square root of a negative, does it exist? In your mathematical calculations, can you simplify square root of a negative? No, these are non-real. Non-real. Remember your grade 9, grade 8, grade 10. So this is the idea that you are telling us, because you can see the number, you can see it. But in our case, like I said, we are going to tell without what? Solving. So that is it. So in the case of nature of roots, this is what we're going to have given. Okay, so given the equation or the quadratic equation, given the quadratic equation, our quadratic equation, which is what? Ax squared plus bx plus c is equal to 0. The nature of a root, or the solutions, their nature can be determined by finding the delta, which is the discriminant. So I'm going to say, given this equation, use the discriminant or delta. This part here is referred as the discriminant or delta, this one, our delta, which is equal to b squared minus 4ac to determine the nature of roots. To determine the nature of roots. So the question is going to be how? I'm given this. How is it going to tell me about the roots? Okay, I want you to see something about this delta part, which is our b squared minus 4ac. So you're going to quickly substitute values. Let's say we are given something like this. X is equal to -3 plus or minus. So the delta part, all right, this part here, yeah, delta or the discriminant. Let's say it is a 0, all right? Let's say it's a 0. I want you to see something. Let's say it's just a number which is 0, all right? Because 0 is our reference number, remember? Where we can say from 0 we go to the negative, from 0 we go to the positive. So let's start with a 0. I want you to see. You were going to use your calculator to find the answers, isn't it? You have solved, you've substituted the values, everything. Here you have what? Substituted everything. This is what you have there. The part that I was saying, please show that part. You substitute that, okay? You go to your calculator, -3 plus the square root. You put a 0 like this over what? Over 2. I want you to see what's going to happen. You are going to obtain -3 over 2. So x is equal to -3 over 2, or you know that it's a quadratic equation. Definitely, you expect to have what? Two solutions. So you're going to do the same thing, okay? You go back to your calculator, you remove the plus, you put what? A minus. You are going to obtain, again, the same answer, -3 over 2. What is happening? But it is not the case when this number here is any other number. Okay, guys, okay, let me do this. You understand me very soon. I want you to see this, okay? Okay, so here, our delta was equal to what? To 0, this part, all right? You understand me very soon. Then we need a delta, which is equal to a positive value, all right? Just a positive value, just any positive value, which is From what? From 0. Any, but not a special number. Remember, special number are like perfect squares. We are dealing with a square root. So in this case, remember a square root of a perfect square, the square root of a 4. We are dealing with a square root. So it becomes special when we are dealing with these numbers. 4, 9, 25. These are what? Perfect squares. So in this case, I just want to use any positive number, any positive, which is not a perfect square because it's a special type of a number in our situation. We are dealing with what? A square root. If our formula had the cube root, if I'm saying if, let's say our formula had the cube root, it means numbers such as 8, we're going to be special numbers. 27, because they are what? Perfect cubes. There is something special when they are affected by the cube root. It is the same thing with our condition. We are working with the square root. So perfect squares becomes special. Perfect squares. So you're going to talk about these numbers on their own. Now, I just need you to see any whole number. Let's just say, okay, let me put this, guys. You understand me very soon. X is equal to minus 3 plus or minus the square root of. Let's just put any number here, which is what? Positive, but not a perfect square. Okay, let's say 5. Let's just put a 5 here and say over what? Over 2. The same thing, guys. The only part that I want you to see is the effect here. Here. Or you see, these ones are still the same. These numbers are still the same, so that you understand me. Okay, let us put our calculator and see. You understand me very soon. So let's go back here and put a plus. We're going to start with a plus. That's a 5 inside of the square root this time. All right, so this is what we have. We are getting an answer. All right, we are getting an answer. Our calculator can simplify and give us an answer. But what type of an answer is this? One, just to exist mathematically, we say it is what? A real number. It can be presented on a number line as a decimal as it is. But it is an endless decimal, which is not a recurring decimal, meaning to say this number or the part that we are having here is an irrational number. We're talking of an irrational number here. That's an irrational number. All right. So I'm just going to use just 2 decimal places here. Shift, go to the setup, fix your calculator to 2 decimal places. I'm just going to, that's minus 0.38. All right. X is equal to minus 0.38. Remember, this was an endless decimal that we had. All right. We do the same thing here. Let's just see, guys, quickly. This one, you know about it, guys, plus 10 introduction. Let me talk about everything. It was going to be the same before you fix up this one. All right. Sorry. Let me do this. Okay. I've already, I just wanted you to see that it was going to be the same even before we fix. So let's go back here before we fix. Let's go back to the normal mode, press 2. That's minus 3. This time we put a minus, right? There's a minus there. So you're going to put a minus. That's minus the square root of a 5 over what? Over 2. So this is it. As you can see, guys, you're going to have an answer which is also an irrational number, minus 2. Here's just rounding off, but it was an endless decimal, right? Minus 2.62. Minus 2.62. So what I want you to see is that the solutions that you're getting, they're endless. Endless decimal that cannot be that cannot be expressed as a fraction. Meaning to say it's an irrational number. We are talking of what? Irrational numbers there. Irrational. Here can be, are you seeing that when it is a 0, it can be used as a fraction, which means you're talking of what? A rational number. It's a special type of a number. The numbers are rational, but here they're irrational. Irrational. Here, guys, we are just using any number here, which is positive. But like I said, perfect squares are important. They are actually important in our simplification. Here we had an irrational number. Yes, we can see that is the same as you can see minus 3 over 2 minus 3 over 2. I thought that I'm just going to write it at the end. No problem. Let me just put it this way so that when I'm concluding, you understand where it is being taken from. All right. So let us just put it this way. I thought I'm going to just put these guys at the end. So we have real, equal, and also the part of being what? Rational. If we check here, irrational, but as just being an irrational number or being a rational number, it means that's a real number. A real number just exists. Square root of minus 3 does not exist. That's we are now talking about non-real. But just being real to exist, guys, square root of 3, even though us, we can't simplify direct, but our calculators can. Those are real numbers. So that is the most important part that I just want you to take note, guys. So here we said real, irrational, and as we can see, these roots, they are not equal like here. All right. So these ones, they are unequal. Very soon, someone will be understanding me. Let's move on to condition 3. We're going to conclude everything. We'll conclude. Don't worry. We saw that this is positive, right? Any positive value. Now our delta, let it be also a positive and a perfect square. Because we say this is it's important. Perfect square. Why? Because there is a square root. We are working with a square root. So these numbers, they become special in our mathematics, in our simplification, not just mathematically, but in this solving of the quadratic equation, because we can simplify the square root of these numbers direct. We even know these ones by head. The square root of 36, these are just direct whole numbers that we have. So we want to see their effect now in the solving of our quadratic equation. When it is under the square root, the part of our delta, like minus 3 plus or minus the square root of, let us just put a perfect square, which is 16. Everything over what? Over 2, just as it was. But the only part that has changed, all right, the only part here that I want you to see that is changing is here. Perfect square, positive. Here it was just a positive number, but here we are dealing with what? A perfect square. So let's just quickly use our calculator and see what was going to happen to our solutions when we have this condition. All right, so from our calculator, we were going to have minus 3 plus the square root of 16, everything over 2. I want you to see. That's 1 over 2. All right, no problem. 1 over 2, or x is equal to, we do the same. We put a minus here. Let's see what was going to happen. We're going to obtain minus 7 over 2. Guys, what is it? Just having answers, just to have answers to solutions, just to say your calculator managed to calculate that value. Your calculator just managed to calculate that value. It means we are talking about what? Real solutions here. These are real numbers. What type of numbers are we having at the end? Look, guys, the first one is a fraction. The second one is also a fraction, guys. Okay, no, let's just maybe let's just say it was a coincidence. Let's put another one, 25 over 2. All right, this one is, I'm not going to change it. I'm just going to change here, the perfect square. Let's put another perfect square, 25. All right, maybe that one, it was a coincidence. And see, the first one, we put plus square root of 25, square root of 25, so that you see, guys, we are getting a 1. All right, so with this one, x is equal to 1. Or x is equal to what? We put a minus this time, all right? Maybe the first one, it was a coincidence. We never know. Let's see. This is minus 4. We are getting minus 4. What is it, guys? Same thing. Remember, these whole numbers, guys, are what? Rational numbers, because it can be written as what? Over 1 as a fraction, as a fraction. So it's simply telling us, guys, whenever there is a perfect square here, whenever we have a perfect square, these roots, these solutions, they are going to be what? Rational. Guys, try put any number. Is it 100 here? Is it a 4? Is it a 1? Or any perfect square. You will see all your answers can be written as A over B, where A and B are what? Are integers, but B is not equal to 0. That's a rational number. All your solutions, they are going to be rational. So the first thing, these solutions, they do exist. They are real. Number two, they are special type of solutions from a special type of a number, which is what? A perfect square. They are what? They are rational. What is the last thing that we can say about these solutions? Are they the same? These two, they are not the same. These two, again, they are not the same. But they are rational numbers, but they are not the same. They're different from a condition that we had here when the delta was 0 here. They had the same qualities, real, rational, but the opposite of being equal. These ones were equal when our delta is what? When we had a 0 here. The equal part. This time, they are unequal. The only thing that they are sharing is the rational part, but they are unequal. They're not the same. This is a condition of a perfect square, what it gives us at the end. So I don't need to solve the equation. I need to know this, what is inside there. As you can see, guys, what is inside can tell us what is going to happen. So the last condition is when this delta now is a negative. Let's just say we've got a negative number when our delta is equivalent to a negative value, a negative number. All right. Let us just put a negative number inside here and see what is going to happen. X is equal to minus 3 plus or minus the square root. Any negative, right, guys? Is it minus 5? Is it, or so this one I'm not going to change, minus 3 over 2. Any X is equal to 3 plus or minus, all right, minus 3 plus or minus the square root of minus 7 over 2. Any negative value that you think of. Let us see what was going to happen. All right. This is it. Minus 3 plus the square root of minus 5. The square root of a minus 5. Like this. Everything over a 2. Met error. This does not exist. Mathematically, we cannot obtain a value from this. It is because of what? The negative there under the square root. We cannot simplify the square root of a negative number, remember. So it means, therefore, we cannot have the solutions at the end. We cannot have the value of X here. We cannot have anything. That's to show us that they are non-real. Guys, the moment you say non-real, don't explain to us about what type of non-real is that. There is no type of a non-real that you try to explain to us. This type of non-real is like the non-real, you're done. There's nothing that you add there. Non-real, unless you just want, or another name, say it's imaginary, to say the roots are called they are imaginary. All right? No, not to say they exist. No, they do not exist. For those who take mathematics further, there is a part of complex numbers there where you work with these imaginary solutions where they introduce a j where there's a negative, or they introduce an I or a j like that in place of a negative. So it will be like maybe x is equal to -3 plus or minus the square root of a 7 with a j like this, or with this I like this over 2. It is not to say it has been simplified. No, we are just assuming it's an imaginary solution that we are putting. Not to say it exists. No, it does not exist. So this is the condition about the delta that we have. All this that we are talking about here, guys, can bring us a solution. Like I said, given this, we can use our delta, which is b squared minus 4ac, to determine the nature of roots. So I just need to know this. I just need this. So in my simplification, I'm not going to simplify the whole of this, guys. Here I was just showing you what is going to happen dealing with your equations. So in your simplification, you just simplify this. You are given a certain quadratic equation. You simplify your substitute values. Then you tell us what is happening. So you're going to just look into examples very soon. Let us just have our conditions, or just like a summary. What can I do? All right, let me put it this way. So I'm just going to have like a summary, guys, about this nature of roots. So we saw that. So we're going to have the part of our delta. Remember, we're going to use our delta. So guys, we're going to have the part of delta, which is equal to b squared minus 4ac, giving us the nature of roots. All right. Then we're going to talk about the roots, which is the nature of what? The nature of roots. So this is it. So the first thing we saw that we're gonna start from the end. When we have a negative here under the delta, remember this is our delta here. This is the part of what? Our b squared minus 4ac. This is the one that you simplify. You simplify that, you see that you get a negative. It means what? The roots are non-real. They do not exist, right? So if our delta is equivalent to a negative, all right, that's if we have a condition where it is less than 0, that's when we have a negative value under the square root. The delta, remember, this is under the square root. When there is a negative value under the square root, we saw that this does not exist. The roots, they do not exist. Under the square root, we have got a negative square root of -3. But as we are not simplifying that part of under this, we just want to simplify this b squared minus 4ac. If b squared minus 4, this is what I'm trying to say. If b squared minus 4ac is less than 0, you just work with b squared minus 4ac. When it is less than 0, when it is a negative, it means the roots, they do not exist. They are non-real. These are non-real roots. They do not exist, or imaginary. All right? Or imaginary. So you can just consider them imaginary solutions or imaginary roots. These are conditions that even, remember, here we are solving a quadratic equation. When you think of a quadratic equation, also think of the functions. Remember the roots of a quadratic function. These are the roots, the solutions, where the graph crosses or passes through the what? The x-axis. So in our case, when we say the roots are imaginary, they do not exist, like in this condition of ours, it means graphically, if we were to represent this graphically, we were going to have something of this nature, guys. This is our x and y axis. We're going to have something of this nature where the graph does not cross or does not pass through the x-axis. This is the condition when the roots are what? Imaginary. They do not exist. Your f of x was going to be like this. Or you were going to have a condition like this, guys, where maybe you have drawn your graph down this side. You're going to have like this. It does not pass through the what? It does not pass the x-axis. There are no solutions at all. There, we consider imaginary. This is what you're going to have when represented graphically. If you take that into consideration, guys, this is what it means for imaginary. All right? All right, so let's move on to another part, guys. We can have, so in this case, we want to take where the roots are real. All right? When the roots are real, we saw that just for us to obtain a real root, just to have a real root, it starts from what? From 0. When, okay, where is it? Here on top. I want you to see about the real root. Where the real root is. It starts when there is a 0 inside of the what? Inside of the square root, there is a 0 there. We have what? A real root. Whether it is any positive value, is it a perfect square or not, there is what? A real root. Whether it is a perfect square, there is what? A real root. This is the condition about our real roots. But when we have a negative, the real does not, we no longer have that part of a real number. So what can we conclude about obtaining a real solution? It means if our delta is greater than 0, but not just greater than 0, because also 0 is there. Remember, take note at 0 there. The solutions are what? They are real. They exist. So the real is there even at what? At 0, even if this part of your delta is equal to 0. So starting from numbers that are equal to 0 under the square root or more than 0, that is talking of what? Talking of positive values. The real part is supposed to be part of your solution. These are real roots. Your answer is supposed to have the word real. Your answer, the real roots is supposed to be there. As long that number is what? A positive. After being a positive, that's where you give us now the special part of it to say, because we are saying being real, guys, I want us to be together here. Being real, just being a real number, we saw that it is happening from what? From 0. From 0. Going up. That is being what? That is being real. But now we want to specify these numbers. Okay, let us specify them now because the real part is there. But out of these real numbers, when it is exactly equal to 0 now, what is going to happen? When it is a real, when this one, the delta, when it is exactly equal to 0, the roots are going to be what? Real, equal, rational. When it is exactly equal to 0. When our delta is exactly equal to 0, remember the real part is there. So it means therefore our solutions, they are going to be real. We're going to be talking about what? The real roots. The first thing, they are real because it is what? Equal to 0. What is the next thing? We saw that they are equal. Those roots that we are talking about, they're also rational. So we can say rational and equal. Guys, let me just put it as a statement. So we're going to have real, rational, and what? And equal. This is the condition now being equal to 0. When there is an equal to 0, what will be very, very important is being rational and being equal, this part. Because already anything that exists on our calculator, as long as it is greater than or equal to 0, the real part is already there. So this one is now giving us to say the real is there, the rational, and also being equal. For being guys, this one is exactly equal to 0. Take note. It can be greater than 0. This is when it is positive. So it can be greater than 0, not equal to 0. Guys, take note. It can be what? Greater than 0. This part that is under the square root, our delta, we saw it. It can be a positive value, greater than 0, like this one. This number 5 here, it's greater than 0, but not a perfect square. So we can have that condition. I want you to separate this properly. So we can have a condition where our delta is greater than 0. Remember, we are separating this one now. Greater than or equal to 0. So we started when it is equal to 0. It can be greater than 0, but on a condition that it is not a perfect square. All right? But not a what? A perfect square. Remember, greater than 0, it means you're talking about what? Positive values. But not a perfect square. Not a perfect square. Not a perfect square, but not a perfect square. This is where we come here. 5 here, this 5. This is our delta. Our delta is 5 here, this number 5. What type of a number is this? It's a positive value. It's greater than, this number 5 is greater than 0. But it's not a perfect square. Look at our solutions. How are they? They are real, irrational, and we said unequal. This is what is going to separate now. So we are going to have real, irrational, unequal. But the real part is there. That is what I want you to take into consideration. So we've got a real, all right? But these solutions will be what? Irrational and unequal. This is the condition of what? When it is not a perfect square. These are the conditions that are going to be part of our solutions. So this is irrational. This is going to be part of our solutions as the nature of roots. So this is what you just need. And the last part that you need is when it is a perfect square, greater than is, because once you say it's greater than 0, you're talking about what? Being a positive value. All right? But being a positive value as it is, guys, being positive as it is, this time we want to look into something special, perfect square. And being what? A perfect square. And a perfect square. This is what we want to see now. It's not just a number, this one. It's a perfect one. What is going to happen? Our roots, they are going to be real, rational, but unequal. Unequal. So we see the equal is only when it is exactly equal to 0. That is where we have the equal roots. Guys, please know this. Understand this. So there we said we're going to have real and being rational but unequal. The roots, they won't be equal, but they will be rational. The most important part, they will be rational. So these are the conditions that we are going to summarize with questions, question papers to see, guys, that we have the basic idea of our topic. This is unequal. So we need to work out the basics of our topics, each and every topic, guys, for you to answer questions, you must understand the basic. These are the basic that you need. So once, most of you, you know this part. Most of you, you understand nature of roots, nature. You can sing even this part, the application. So take note, guys, delta, you just need to know this. The delta, this one, b squared minus 4ac. B squared minus 4ac. But look what I said. It must be from where? Given this, this is the format of the equation first. It must be in this format. One side equal to 0. All terms on one side of the equation, one side equal to 0. You find this b squared minus 4ac. That's the one you are going to use in comparison. So in our question, we're not going to waste much time, guys, to look into or to just give a basic view of this part. Then we're going to look into question papers thereafter. There we are just given, consider the equations and match one to the statement which best describes its roots. Consider these equations. So in actual sense, they are supposed to actually tell you, do not solve. You are not supposed to solve. You just look into the equation, then you tell. So let's start with the first one. So these are the answers. All right. So the first question we're given, x squared minus 7x minus 18 is equal to 0. That's a quadratic equation. Already the format, guys, we already have our format of ax squared plus bx plus c is equal to 0. We already have the format. So what we just need is to determine the delta. All right. So let's see, guys, on this one. What is our delta? Remember, I said delta is equal to b squared minus 4ac, which is equal to what? What is our b? Take note, this is our a, our b, and our c. So our b is what? Negative 7. So you simplify that. Negative 7 squared, all right, minus 4 times a, which is 1, times c, which is negative 18. You simplify this. So guys, just for the sake of time, I want you to simplify this on your calculator. You are going to obtain 121. So looking into 121, how can we put this number, guys? Which part can we put under this list? Because this is your delta here. It lies under which list? Is it a negative? Is it a positive, just only being positive, just to be greater than 0? Is it a condition where it's greater than or equal, when it is greater than 0, but not a perfect square? Or it is a perfect square? Which condition are we having there? Because that is your delta, this part. So in our condition, we can see that this is 121. This is a perfect square. So how do you see that it's a perfect square? Use your calculator, simplify that number. Let's say you are in exam. What is the square root of 121? It's 11. We can simplify the square root and obtain what? A whole number. That's a perfect square. The square root of 100, meaning to say 100 is a perfect square. So we saw on this one, the square root of 121 is what? 11. So this number, it is not just a whole number. It is a perfect square. We are dealing with what? A perfect square in our condition. So in our case, our delta is a number which is greater than 0 and a perfect square. So which condition is it that we are going to put as our final consideration to say it is greater than 0 and a perfect square? What is it about the nature? This is the nature of the roots now. Real, rational, and unequal. So this is what we're going to have. So which part has these three? Real, rational, and unequal. This is what we need. So you're going to need real, rational, and equal. So this is what we have here. Real, rational, and unequal on part what? On part B. So this one was going to be what? Part B. This one. This was the best solution. B. This one. So 3.1, you're going to take what? B. where they are real, rational, and unequal, just like that. So this is how you're going to solve these equations. I mean, these questions in our case of the understanding of the nature of roots. So the same part, guys, even 3.2, you do the same thing. You are given 25x squared plus 20x plus 4. That's equal to 0. So you do the same thing, guys. B squared minus 4ac. That's our delta, remember? So what are you going to have? This is your A, your B, and your C. So in this case, you're going to substitute B squared, which is 20 squared, minus 4 times A, which is 25 times C, which is 4. So simplifying these, guys, you are going to get a 0, exactly equal to 0. And when it is exactly equal to 0, this is what we have: real, rational, equal. So these roots, they are real, rational, and equal. Where do we have that? Real, rational, equal. That is A. So the best answer there was going to be A. Your delta, B squared minus what is it that you're having? It is exactly equal to 0. All right. So that is the condition there. So moving into 3.3, looking into this, we're going to have 2x squared plus 7x plus 4, that's equal to 0. So that's our A, our B, and our C. So taking delta, which is B squared minus 4AC, we're going to have our B, which is positive 7, minus 4 times A, which is 2, times C, which is 4, like this. So we're going to have the part of our delta at the end. So just like that, guys, we are going to obtain positive 17. All right, so that's positive 17. It is a number which is greater than 0, as you can see. It's bigger than 0 because it's positive. But what is it? Is it a perfect or not? Because when a number is greater than 0, it must be described to say, is it a perfect, is it a condition where we have it as a perfect square or it's not? Is 17, this number, a perfect square? It's not. So if you do not know, guys, use your calculator. What is the square root of 17? All right? What is the square root of 17? Look into your calculator and see what's going to happen. We cannot simplify it. That's an endless decimal. Meaning to say, that's not a perfect square. Not a perfect square. So this number is not a perfect square. Yes, it is greater than 0, but not a perfect square. So meaning to say it is going to best suit these solutions: real, irrational, unequal. So which part do we have? Real, irrational, unequal. That's to be on C. So this was best to be C. All right, just like that. So guys, that was your condition there. Then looking into the last one, we've got 3x squared. That's 3.4, which is 3x squared minus 5x. All right, plus 3, that's equal to 0, like this. So we've got our A, our B, and our C. Remember, this side must be 0 there. So what is our delta? B squared minus 4AC. So simplify your delta, guys. What is our B? Minus 5 squared minus 4 times A, which is 3, times C, which is 3 again. So using your calculator, guys, properly, you were going to get a negative 11. Negative 11. Our delta is a number which is less than 0. To be negative, it means we are less than 0. So there we do not have roots. They do not exist. Mathematically, there is no solution there. They do not exist. So these roots, they can be referred as imaginary roots. Not to say they exist. No, they do not exist. So you're going to take imaginary roots, which is what? Non-real. Or which is what? Which is D. So this was the condition, guys, of our nature of roots. So I want you to work out questions, question papers. Actually, there is a lot that we are going to make as adjustments. This was just an introduction to know the basic view of what you're going to have as you're going to be working with question papers. But for now, I want you to work out this part, understand this part, guys. I don't know how you're going to work it out to understand this, but I think I described best to understand this, guys, just knowing the basics of an equation. Just knowing this, guys. Like I was explaining, when you have a zero, when you just put those perfect squares where there's a perfect square and see what is going to happen on your answers. Form any way, any setup of a quadratic equation when it is in this form. Put a zero there. Put here under the square root, have a zero, and see what's going to happen with your solutions. Your solutions, they will be equal. Any part that you want, guys. Let's say it is 3 plus the square root of 0 like this over 7. All right? This one, you need the square root of a 0 like this over a 7. We are going to obtain 3 over 7. Put a negative here. Put a negative here. You are going to obtain, again, 3 over 7. So in terms of the roots, if you're to talk about this graphically, this is this one. When they are the same, this is a condition when you're going to have it graphically like this. Graphically, you're going to have a condition where the graph passes at one point. It only passes through one point like this, where maybe x is equal to 2, whatever that you're having there, or is 3, whatever that you have, at one point. Maybe your graph is this way. It only passes at one point like this. It curves at one point. That is the solution. So there are two solutions. Remember, it's a quadratic. So a quadratic is supposed to give us what? Two solutions. But it will just pass at one point. On this condition, we are going to be having what? Solutions that are not the same. So meaning to say, in this case, when we have got positive values, but not a perfect square. Remember this one, not a perfect square. Not a perfect square. Graphically, guys, we're going to have something like this. Two solutions. Actually, there on your graph, maybe it's like this. But these values, they are not exact. Even on your graph, you cannot like obtain these values direct to see, okay, this is -2, or this is, you cannot have this exactly because they are endless decimals. Remember, they are irrational. But it can be drawn. Only that here you cannot have an exact, like to say the answer here is 3.1. Yes, on our graph we can approximate, but that one, it does not mean that was the value. We are just using an approximation there. All right? That was when it is not a perfect square. But when it is a perfect square, we are going to obtain numbers that are reasonable because these are rational numbers. Yes, they are not the same, but the condition, guys, will be like this one. So this one, it can also be like this. As long they are what? As long there are two solutions. In the same manner, it is the one with this one. It can be like this. When it is what? A perfect square. They will be different, but these numbers, at least they are what? They are rational. Rational numbers, guys, we can even locate some. Yes, it can be difficult to locate some of these because some of these can be 1 over 3. 0.3333. It's a rational number, but to locate it on the graph, it is difficult. But it is the same situation with this. The only important part is that these ones, they are rational. But the same condition of the graph to say it is going to pass through the 2 points. One at this point, another one there. At different points. At different points. When it is a negative, it does not even cross the x-axis. Does not even cross the x-axis. That is when it is given graphically. Because they can give you a graph. They can give you from a graph. So you just need to work out as many questions. So guys, I think for this part of our introduction, I think this one is enough, guys. Just make sure you go through questions from your textbooks. Then we're gonna bring you question papers very soon to cater for your revisions. But as you can see, some of these questions, we have been doing them in full question papers as we have been doing question papers, only that we haven't done it as an introduction. So for most of you have been asking for the introduction of the topic. This is our introduction, guys. So we can add more information to those questions that we have been answering in those question papers. To now they can make sense to say, okay, this is what I was trying to say. So let's do as many questions as we can.